Welcome to Chapter 1. Make sure that you have a notebook, pencil, and periodic table available so you can write down the notes as you see them occur in this video. Chapter 1. Chemistry is the study of matter and its changes. And matter, of course, is the stuff that makes up everything, and we look at how it changes. Our textbook is called Chemistry, the Central Science, not because it's the most important piece, but because it's central to the science and understanding of so many other areas of technology and engineering around us. And so chemistry connects to lots of things in everyday life because lots of everyday life has to do with matter, has to do with stuff. And so if you're going into medicine, engineering, pharmacy, geology, or biology, there's connections between all those things. Chapter 5 in our textbook shows how it connects to medicine, how it goes to biochemistry, how it connects to the energy around us, and how it connects to technology and the uses all around us as well. That's the study we're going to do this particular year. So what is matter? Well, all matter is made up of about the 118 or so different elements that are outlined on the periodic table right here. And the basic building block of each one of the elements is called an atom. The atom is the smallest, for the most part, indivisible part of matter. If you have two atoms together, then you have what's called a molecule. And our book likes to illustrate molecules or atoms with spheres. And you can see on page 4 that a white colored sphere is hydrogen, a red colored one is oxygen, and a grayish black colored one is carbon. And you can see an oxygen molecule would be two oxygen atoms together. Here's a water molecule, with one oxygen and then two hydrogens. And then you can see how the spacing together of carbons with oxygens and hydrogens make different molecules of different substances that maybe you've heard of. Becoming familiar with how these are illustrated in your textbook, it makes it very easy, or much easier I should say, to understand a lot of things that the textbook and of course the video lectures will tell you along the way. So currently there are three main states of matter that we see here on Earth. The current states of matter that we see here on Earth for the most part are solid, liquid, and gas. And I have those illustrated right up here as S for solid, L for liquid, and G for gas. And the change in between those different classifications are one of the pieces that we study. And you can see that water in the solid, liquid, and ice, or solid, liquid, and gas stage right here are illustrated by the differences in how far apart the molecules are. You can see that water vapor right here has lots and lots of distance between the particles because it's in its gaseous stage, whereas the ice particles have a really rigid set up way of organizing themselves, and they're very close together compared to the water vapor stages. So we classify matter in several different ways. But first of all, there are these things called pure substances. And pure substances are either elements, which are one of these things on the periodic table, or they're compounds, like water or carbon dioxide. Elements have only one kind of atom in them. Compounds have two or more different kinds in them as well. Each one of those would be a type of pure substance. Carbon dioxide, a pure substance, but it has two kinds of atoms, carbon and oxygen. When we classify matter or pieces, we look at whether the matter is heterogeneous, meaning that it is different throughout its composition, or homogeneous, meaning that it is the same throughout its composition. And heterogeneous substances would be things that would be like rock and sand and water all together in the riverbed, or maybe in a bucket, or oil and water that don't mix together very well. In your textbook, on page number 11, they actually have a really nice diagram, just like this, heterogeneous mixtures right here. The other type of matter that we would classify it would be homogeneous, meaning that it's the same throughout. And so here's where we encounter our pure substances, which we just talked about up here, which would be elements or compounds, or homogeneous mixtures, which have another name that means the same thing, also known as solutions. So homogeneous mixtures, when people hear the word solution, usually think that means it involves a liquid or involves water, and it certainly could be. Kool-Aid dissolved in water, stirred up really good, could be a homogeneous mixture. It definitely could be. It could be a Coca-Cola. It could be a substance that is dissolved in water like calcium sulfate and mixed up really good. But solutions can also be solids dissolved in solids, gases dissolved in gases. Fog, for example, if it's the same throughout, could be a good example of a gas dissolved in a gas that you can't see very well. An example of a solid dissolved in a solid would be something like white gold. Gold that has another metal mixed in it and then is frozen or put into its solid state, which it is at room temperature, maybe mixed with silver would make it be what's called white gold. Pure substances, on the other hand, only have a constant composition and are made up of two different things that aren't necessarily dissolved in one another, but are chemically combined with one another. For example, an element would be gold, or maybe something like oxygen, or something else that is only on the periodic table. If it contains more than one kind of atom, like H2O, like CO2, like NO2, then it would be a compound because it contains two or more types of substances. In our next video cast, we'll look at properties of this matter, but make sure that you've got this diagram understood and the classification words that are used for matter.